Okay, so the idea is how do we create light shelves like this and kind of do that and sort of understand how to like do that kind of easily. So what I'm going to do is I'm just going to make a real simple little wall, and this is actually what I'm going to advocate you might want to think about doing for this first assignment, is really going through and you'll ultimately kind of think about, oh, what sort of qualities of the wall. For right now, I'm just going to go ahead and choose kind of the generic wall. We can go ahead and make it something a little more interesting in a while. I'll go through and even do something as simple as just kind of making a single wall. Okay, and then with that single wall, let's go ahead and just kind of put a floor and kind of a roof on it, just so we have something to work with. So let me go through and I'll choose that one wall as a starting point, but then I will just sort of draw some floor over here. And I'll even go ahead and put a simple little roof on that too. So put a little roof in here on level 2. And I will pick this first wall. Maybe I'll give it a little overhang. 1 foot's good for now. We'll leave it for that right now. And then I'll draw the other lines because I don't really have an entire structure just yet. Let's take a look at how well we did here. So I got a real simple little building here. And in terms of that building, I could go ahead and start putting in some different features. Actually, let me do this because I didn't really do a very good job of that. Let me go ahead and reorient it so it actually is facing south as opposed to the north. Well, the north is sort of equally valid at a different time. Maybe I'll leave one north and I'll do another one south. I'll just copy this. Stop that. Over there. But what I'll do with this one is just rotate it around 90 degrees. Just look at it from this side now. I want it that side just so the sun is shining on it for this simple example right now. Okay, so we'll go through and put a window in there. We could do this with a curtain wall. We could put it in a window in there. Let's think about how you can model this kind of simple shelf. So if I go through and put in something like a window and another window. Okay, that is so far so good. If we wanted to go through and model a shelf on that, have any suggestions? How do you think we might put a shelf on that? A lot of different ways we could do it. Yeah, this. We just need a horizontal surface of some type. And so we could do that as some sort of a generic mass. We could do that as some sort of special purpose part. We have to find parts that are like shells. But let me kind of give you a way to do it that I think is actually really good. It's actually if you make a little roof. And this is going to sound really, really goofy. But a roof actually works very well for doing these shells. Because the nice thing is, if we take it to some of the analysis programs, that roof will come across and be considered a shading surface or a reflecting surface. So it gives you a little more information to work with. So let me show you what that would look like. So in terms of doing that shelf, we can go ahead and I'll just put it on, let me go to level 1. The floor plan will be a little bit easier to see there. This is my south facing one over here. Let's see if I can even find the window. I believe it is somewhere hanging around over there. So if I want to go through and create a little light shelf like that, what can I do? What I often do is I'll go through and just create a roof by footprint. I can put it at level 2. Actually, I'm going to put it at level 1 and give it a little bit of an offset. Let's talk about that. So where do we want to put it relative to level 1? I want to put it at some height above level 1, wherever we want to put that. We can put it right at the top of the window. That's the way a lot of people would do it. So I'll just put it in there at 6'8". I'm hoping it's somewhere around there. In terms of the roof, do I want a big old 12-inch roof? I probably don't want a 12-inch shelf, so I want something a little leaner and meaner. So let me go ahead and just duplicate this, and I'll say it's like a shading shelf, maybe 1 inch thick. And then I can go ahead and give it a new structure. I'll just make it 1 inch thick. Now, in terms of that shading structure and stuff like that, in terms of really understanding its performance, I can't just kind of leave it with no material, but if I want to start actually having it have the right thermal properties, having the right, really I'm most interested in the reflective properties and the light blocking properties. Question? You're stretching. No worries. What we can do is try and choose some sort of material in here, and oh, what can we find in there? We could choose some sort of metallic surface. Generally what I tend to do is actually go for sort of very bright surfaces, like white painted surfaces, things like that. So what could I do? I could take, metal deck. What do I want? I just want something very white and bright. I'm just going to call it paint. Parking stripe. See if I can find some other interesting things in here. I got a little browser here that lets me actually find some other things. Steel, fact, paint finish. Ooh, ivory glossy. This is looking better. Ivory matte. I'll go for what I really want is white. Blue. Metal, powder-coated white. That sounds pretty good. We'll go for that. And what I'm doing by bringing that in there is I'm giving it a specific appearance. If I want to go ahead and amp it up a little bit, yeah, it has some different properties here, including it has some physical properties. So we're basically looking for something that's going to go ahead and have ultimately some reflectivity. Although I think that's just going to be controlled back over here in the appearance. So in terms of the color, yeah, if I want that to be even brighter, I'm going to turn that up and say okay. But I'm just going to go for some bright white surface because ultimately I want it to be able to reflect an awful lot of light back up. So let's go ahead and say okay to that. We are ready to kind of create our shelf. For my shelf, I will just do something as simple as this. Okay. The length will ultimately be determined by how deep it needs to be to go through and do the shading that we need to do. Let me just go ahead and finish that up for right now. You don't see it right now because it's actually above your head because the cutting plane's at like 4 feet and it's sitting there a little bit higher. Let's take a look at that in 3D. Okay, that wasn't too bad in terms of what it is. So this is going to have some sort of an effect in terms of what we want. And if we need to, we can go ahead and copy that over. Kind of put another one over here. Put it on that window too. So we can approach it like that. And that's actually sort of a perfectly valid way to approach it. In terms of what we're doing here, though, it's accomplishing a lot of shading. It's not accomplishing a lot of reflecting. So if you want to actually have it be a little bit of a reflective surface too, not to worry. What you can come on do is actually go through and just lower it. So we can figure out what level we think is optimal. We want it to be high enough so no one's looking at it, but it still has the opportunity to reflect some light up. And whether that's 6 feet or 5'10" or whatever it is, we can lower it on down and then start to having that lighting effect in terms of reflecting things back. Now, in terms of doing something like this, we can do things like this just individually and in a very ad hoc way. And as a starting point, I tend to actually just model like this. I'll put them in and sort of try to gauge what the effect is by just kind of adding in shelves in a very simple way. What we're going to learn, though, is we can actually get sort of pretty sophisticated about this. So, for example, we have this big old window, and that's kind of okay. If we'd like that big old window to have a shelf built into the window object, we go through and do that too. So let me kind of show you what that looks like just really briefly. So you just sort of know where it's going. So I can say, let's go ahead and edit that family. Okay, this is the window family, and we don't think very much about it in terms of like its properties, but if we want to go through and change it, let me go to the floor plan view. Okay, we can actually go through and add things to it. For folks who were in the 120A class, we played around with creating different parts and families and adding to like different pieces to kind of customize things. We could do a similar sort of thing here where we could go through and create something that's going to be something like the shelf. I can go through and align it so that it goes to the ends of the window and lock that in there, and align this over here and lock that in there. I could even do things like, pull that in and lock it to this. And then if I'm really groovy, I can even go through and add things like, the depth of the shelf is a parameter. So we can go through and change that really easily. And if we wanted to do something like that, it would be something like just adding a dimension. I should actually do it with a reference plane. You can yell at me and say I didn't do it that way. But I can add a dimension here and say that this thing over here is going to be a shelf depth. Okay, but I can go through and create something like that and really make it all quite parametric and add it in there. Now, I've done that really quickly. This isn't complete in terms of what's going on right now. I just want to sort of illustrate the principle. But let me kind of show you what that looks like. I'll switch to an elevation view. You can sort of see it's down here on the floor right now. I want it somewhere back up in here. And in the same sense that we can add all sorts of parameters, we can add a thickness to it and a height or a depth from the top of the window. But what is the advantage of doing it this way? It's going to show you. Okay. If I now use this window, let me put it back in over here. See what's going on. Oh, actually, it flipped around. A shelf's on the inside. You can decide whether you want a shelf on the inside. Let's see if I can just flip it. There it is. Flip the facing. Where'd it go? Phew. There we go. The nice thing about doing it parametrically like this is that if you do go through and you, for example, create a different size of window, let me duplicate that. Make it 60 inches by 72 inches. The groovy thing about that is that, width, height, 60. Why does width sound so strange? Only a foot? It was 36. Width down there. I'm looking at the wrong thing. Default sill height. Never mind. Okay. It's smart. It'll adapt and do things like that. So you'll learn to start, in your toolkit as special parts for doing sustainable buildings to build your own little pieces. Okay. And if we give that the right properties, it'll kind of be useful in all the analytical tools. It'll go through and take care of things the way we want. Okay. So definitely think about how we can use shelves to do something like that. Other ones we want to think about, there's this whole notion of these vertical or horizontal louvers that are parallel to the wall. Let's talk about the advantage of that. The nice thing about this is that a scheme like this not only kind of blocks the sun, it actually lets a lot of convection, lets the kind of air move as opposed to blocking it and trapping it. So just another approach. It's very effective at blocking the sun, but it kind of works very similar. This sort of scheme, I would probably do this as some sort of a part or some sort of an addition to the window to go through and create something like this. You could do it as a bunch of little roof segments. That would work too. But I tend to do it more kind of as a part to add something like that. Angling them, similar effect in terms of what's going on. We could create a part that's actually very smart in terms of actually letting us be able to control the degree of angle. So let's talk about that in terms of the degree of angle and why you'd want to do that. Relative to, let's go back over. This guy, he's going to block the sun all the time, very, very consistently. Okay. This guy over here, he's going to block the sun most of the time, but there are going to be times when he doesn't block the sun. It really depends on how tall those louvers are and whether the geometry works out so it's blocking it all the time. Angled louvers attempt to kind of do that a little bit smarter, but have you seen buildings yet where the louvers actually adapt and change throughout the day? And they just sort of respond to the angle of the sun constantly. And there's this whole concept of really having buildings be living architecture that can constantly sort of adapt and change and be smarter about that. Because really, as the conditions change every day and are a little bit unique, the idea of having the building respond to that and be smarter is really kind of cool, as opposed to just considering a static structure. There's combinations like this, which are the big shelves in combination with louvers that kind of come down that way. Now, let's talk about louver systems like this, because when we get to louver systems like this is where I'd actually probably advocate doing it a little bit differently. Because louver systems, especially the ones that are stacked, they lend themselves very well to the whole curtain wall tool. Because the curtain wall tool is really, really good at kind of making very regularly gridded and spaced systems. Let's think about how you can use that. So, okay, let me go back over to Revit. So here I am. I've sort of been playing around with my little wall surface right here. I'm actually pretty happy with this little wall surface in terms of what's going on. For this, if this is one of the strategies I want to consider for my south walls, let me show you what I think is actually sufficient for just sort of expressing that. Because I just have this big old wall floating in space. It's not really looking very good in terms of a whole building. But let me show you how you can actually kind of start thinking about sections. So for this window on the wall, what I can do, because we want to share with everyone and kind of show what you have in mind in terms of how this window scheme is going to work, we can go through and do something like this. Cut a section, okay, which is kind of a nice way to get started. Okay. That section view creates this nice little 2D representation. That 2D representation is very cool. Yeah, whatever. We understand it as an architectural drawing, but it's not nearly as expressive as what you can do. Okay, so my little section that I've created here, and I'll just rename it. I'll call it South Window 1 because I kind of want to be able to find it in a list later. Okay, looking pretty good. What we want to do is say, hey, I love that so much. What would it actually look like in a 3D form? So what I can do is actually right-click on this and make a 3D section that actually matches it. Now, you're saying that doesn't look very 3D. That looks pretty flat. But it's really just a flattened out version of it. It's kind of hanging around over here. So what can you do? I'm going to go ahead and push that out of the way. I'm going to change that so I can pan over there. It's perfectly okay and appropriate to think about actually just creating a series of little wall sections like this that really go through and illustrate your different design concepts. So you can show a wall section like this that shows us really how the sun is hitting the wall, really what's happening with your overhangs, what's happening with the shadow behind it, and do it for a number of different systems. So we could think about a system like this, which is kind of very, kind of illustrating one of the concepts that you might be considering from your walls. Another concept you might want to consider that you could illustrate is something more like this. Let's go ahead and I'll go back to just the big 3D view. Let me save this one away. I really want to save this away so that I can kind of capture it later. So I'm going to basically just duplicate this. I'm going to call that just wall section 1. If I want to illustrate another concept, I could do something like this. Let me go back to the big 3D view. I'll just turn off the section box. We'll see what that looks like. What I'll do is try a different window type. For example, one thing I might do for a system like this is instead of going through and having the shelves in here, go through and just put windows very high on the wall. That's kind of another approach that works pretty well. Let me kind of show you what I have in mind. So another perfectly valid approach is, as opposed to my funny fixed window, actually I should have saved that under a different name. That would be better for me. Let me go ahead and load in a different window type. I'm going to load in, like an operable window, like a transom window or an awning window. We'll talk about what these would mean in just a second. But I might go through and load in something that looks like this. Oops, I actually want to go in the other direction. Kind of something that's kind of very wide by very tall. Or not very tall. So let's say only about 16 inches tall by 4 feet wide. So another very valid approach would be to do something like this, to take these little windows and actually put them in very high on the wall. See if I can get those oriented right so they actually look better. Actually, I won't be able to see them because they're too high on the wall. Let me kind of fix them so they're at the same height. So this wall and this one over here, let's give them an even sill height of like 8 feet tall or something like that. See if that looks good. Okay, pretty high on the wall. You know, what we can do now is, in that same sense, come back over. Yeah. Basically cut a building section. It's a little hard for me to see here. Let me go to the ceiling plan. I might be able to... Nah. I'm cursing myself by basically putting things up high on the wall, which I should fix for you. What I can say is, oh, give me a view range in here, a plan range, where I'm going to show those taller ones. Okay, and again, if this Revit modeling is kind of looking a little bit gronky to you, don't worry about it too much because you don't have to do all these. I just show a lot of different techniques. Oh, 7'6" isn't going to work because I actually put those windows at 8 feet. Never mind. 8'6" with a cutting at like 8'2". There we go. I see them now. So in the same sense, I could go through and put in a section over here. Let me flip it around. Okay. This again is going to be my south window type 2. Okay. Same sort of thing, come on in. Let's kind of create a little section that's just for the south window type 2. And again, orbit that around. So what I'm going to suggest to you is actually, as opposed to going ahead and designing the entire building, a good way to get started with this is to really go through and just create some different little wall sections, just sort of showing us what you have in mind for these different conditions. You know, for the south side, which is going to be the south side will definitely be the most interesting one in terms of how you're addressing the sun and the shading. You know, the north and the east sides and the west sides, they'll have their own special things going on. North, we're going to get a lot of daylight out of. East and west, we'll get morning and evening sun out of. But just going through and creating different wall conditions like this is actually pretty good. Let's talk about the advantage of doing something like this. Why do you go through and put windows very high on a wall like that? What is that good for? It's not good for view. I can't see out. Like a lot of times when you don't want people looking out, you put them up that high. But what does it allow you? It's light in, it also gets ventilation in if we want to do something like that. So if that's your concern, you know, these very high windows is a very common strategy, especially in a lot of exhibition spaces. If you have something where you want people to focus on the inside of the room and what's going on there, not necessarily the fantastic view, okay, this is not a bad strategy to be using. So even in your center, as you think ahead, think about times when you want a fantastic expanse of glass that people are looking at and enjoying the view of the bay. And then think about times when they don't want that. Because honestly, one of the tricks in architecture you need to be aware of is if you make the entire building this fantastic glass box that has 360 views all around, nothing is special. And it is just all the same. So part of one of the tricks of architecture you're going to learn to play with is that if you really want that room that is glassy to be very, very special and a breathtaking experience, go ahead and create other parts of the building that aren't so breathtaking. Or control light in different ways. Kind of have a little bit of balance between all those things. And you don't need 360-degree glasses all side. Like, oh yeah, you don't want it all times. That wouldn't be a very good illustration of your sustainable design principles. So think about how to use those at different times. Okay, now, in the case that you want some beautiful glass and you do want to put a curtain wall in there, let's talk about how you can do that real quickly. So go through and put in a curtain wall. Let me kind of put in a couple different ones that I can put in to kind of take a look at. I can put in a curtain wall, let's say wall, architectural. Put in some sort of nice glazed wall here. I'll get sort of this exterior glazing one. Or actually, let me put the one in with Let's put the glazing one in first. I'll go through and put that in. It's going to be hanging around looking pretty good. Take a look at that in 3D. Let me turn off the section box again. Zoom on out so we can see where it is. There it is. A little hard to see what's going on, but it's hanging around right there. So I got this big piece of glazing in there. Now, for this piece of glazing, if I want to, I can go through and add the fins directly to the glazing. And a lot of people will do stuff like that. They can add shading devices to it. So how did we do that? I created a couple different types that did it. For example, there was the horizontal shelves where really all we did was we took for the curtain wall. There's this notion of really what the spacing is, the vertical spacing and the horizontal spacing of any elements, and what the sizes of those elements are. So you can create the verticals and you create the horizontals and really adjust those. So if you want a 24-inch shelf, we can put that in there. If we want to go ahead and space it, as opposed to every 5 feet on the horizontal grid, that's every 4 feet. If you want a different sort of spacing in there, if I want to go through and make it a 3-foot grid or whatever it is, I can go through and do that. Another way to approach this, though, if you want, is you can go through and actually customize this to be exactly what you want. So, for example, I could go through and put in that wall. I'll just put in the exterior glazing again. Okay. And if I want to start customizing that, if I don't want really an incredibly regular spacing, I want to have something where, it breaks at an uneven increment. I can break up the grid myself. I can just go ahead and put in a line here, here, here. And then if I want to add mullions to that line, if I want to add the fins to those lines, what I can do is use the mullion tool and say, let me just put it on this line. And then within those mullions, if you decide you want to change that mullion, you can see if I can tab to get it. Well, that's interesting. It's only going to let me get the one in there. Now think about how I get them all. But I can go through and change to a different size and kind of like really start to be very fine and articulate exactly how I want that pattern to look. Now, that's kind of all cool. Another thing we can do with curtain walls, though, that we should think about is, curtain walls don't always have to be clear glass. You can make them translucent, you can make them solid panels. And you have the ability to go through and change those things too. So for example, if I want to change a panel here to be a solid panel, I can do that. I can create a type which is a glazing, which has special properties, has like a translucency. Maybe on the south side where we're getting all the solar, I want to put some sort of special low-E glass with a high solar heat gain kind of blocking factor, so I can do things like that. So we can change the quality of the curtain wall itself. But the final technique I want to talk to you about and show you is this, and that is go ahead and you can put the wall in, because a lot of buildings are done this way now. Okay. After you put the wall in there, if you'd like to go through and actually add some sort of like a grid system to it, you could actually do it on the outside of the building and really have more of a screen element kind of hang around the outside. Let me show you what I mean. Let me go through and in a similar way get those notion of like, the horizontal shelves. I'll put it out here. So I got my wall of the building. I have some sort of other wall in here. Okay, and you're thinking, okay, well, kind of interesting, but why do I want the two different walls there? And if you don't want the two different walls there, what you can actually do is this. For that screen out here, let me go ahead and just edit this type and duplicate it so I can keep the original around. Let me call it screen only. Okay. We can actually change it. We can change the panel to be, instead of a glazed panel, we can change it to none. Okay. Oops. Still looks like it's glazed. Hang on. Curtain panel, none. Horizontal grid. Function interior, screen. Oh, did I change the wall type? I think I did. Why does it still look like it has glass? edit it. Vertical grid, continuous, fixed distance. That should all work. That should all work. 4 feet. Let me see what curtain panel none is. Something is strange, because I shouldn't be seeing it there. I can take it out there. In fact, I can even go through and I can take out these mullions if I don't want them. But why is that? System panel glazed R1. System panel glazed. Okay, so what's the difference between my system and what's showing up in there? Is it a type property and I'm just missing it? Let me think about it. I'm a little confused. This is typical. But in particular this time, system panel glaze. Oh, empty system panel. I'm sorry, not none. There's always a way. Okay, and now we just basically have a series of sticks. We don't actually have anything in there, and they're actually filtering. So again, we can kind of keep on editing this. We can say that, for example, it doesn't have any borders on the horizontal. Change those to none. We could change into round ones. We could actually, oops, that's the one we actually did want to keep. None and none. So you can go ahead and use the curtain panel to actually do all sorts of interesting things, just with a little bit of creativity. Don't be afraid to kind of think about it in a slightly different sense. Sure. I thought more of them would go away. Well, we'll leave it at for now. Okay. So we can go through and have this notion of a screen wall that's in front and actually play with that very, very creatively, having different types or different sides of the building. Because even in terms of a screen wall like this, you recognize you probably don't want to have the same one on the south side and the north side and the east side. It'll be a little bit different. You can customize them for those different things. So for the assignment, or for just getting ready to check in next Tuesday, really the best thing to do is think about the different wall conditions on the different sides, when you want to capture a lot of light, when you want to have some view, but you want to provide some sun shading, when you want to have a wall that just has a big thermal mass, because that's going to be part of what you're trying to do there. And just see if you can come up with different wall sections for really what some of those different conditions would look like, and then really where the different wall sections would apply in your building. Is that a north side section? Is that a south side section? It's really where you want it to apply. Yeah. Less about the entire form of the building, but think about those. Okay. Now, a couple more things I want to get at as we're finishing today. A couple more different schemes. Oh, about the louvers, that's all fine. In terms of windows, a lot of interesting stuff about windows in the documents that are on the server in terms of different types of windows and how they open to allow ventilation in. One of the biggest things to sort of read in all this is there's a discussion about metal windows and wood windows. And the metal windows, the important thing you have to know about metal windows is metal actually offers this path of conduction right from the outside to the inside. So the very important thing we're seeing in all metal windows these days is these little thermal breaks. We'll put breaks in there so the heat just can't conduct right through the frame, which sort of defeats the purpose. You have this really high performance glass, but it comes right through the metal frame. The other thing you need to sort of know about windows is this. Wood frame windows, okay, which aren't used so much commercially, but are very commonly used residentially, are a little bit better from that standpoint. Wood frame windows often, just as part of the very construction, don't have or have fewer thermal kind of couples between the inside and the outside. But even for these now, they're really coming up with strategies to introduce thermal breaks. The idea is you don't want to have a conduction path, because the heat's going to go out or in through the weakest link. I thought this was kind of interesting in terms of glazing, because as people were working with glazing, I really kind of got stuck on the issue. Really, what is the difference between low-E glazing and tinted glazing, and really what is the effect? And I actually found this table that I thought was actually pretty good. In terms of double plane clear versus low-E versus tinted glass, you can actually start to see what the effect is in terms of how much of the visible light is cut out versus how much of the solar radiation is cut out. Okay, so in terms of really what's transmitted, so for clear, you're getting anywhere from 60 to 76. For low E glass, that tends to be all about cutting down on the amount of solar radiation that's coming through it. They tend to also have better U values, so the conduction's better. But low E glass, you're also going for a better conduction, but it's also cutting out the solar radiation. So you have to decide whether you want that or not. If you want to try to use solar radiation, you're sort of working against yourself. There's also just, coated windows that are coated with different types of materials. You can see that really they have this incredible effect of, clear glass being 70 to 80% of the light being transmitted. Even low E glass doesn't cut out the amount of light, it just cuts out the solar radiation in the light. Okay. Where these reflected windows, they're huge. They actually have a very big effect in terms of cutting down the amount of light. A silver-coated window actually cut out like 80% of the light, or something like that. Which, from a daylighting perspective, if you're worried about the exhibits and then getting too much daylight or being in an uncomfortable space because people are baking in the sun, just a coated window could actually do what you want to. Still preserve the view, but kind of cut down on the light, stuff like that. Also, it's very good at cutting down on the solar radiation, but these tend to be more expensive. So we tend to work up in here. There's more special purpose coated cutting as you go down. Okay, so let me give you one last concept just to kind of finish up, and that is the whole notion. I'll leave skylights out, but skylights are, again, a good topic in terms of thinking about light and how light actually reflects down into a space. Let me comment on one aspect of skylights right here. When you have a sun tunnel, when you have a tunnel coming down the skylight, actually it does a better job of daylighting the space. What happens is, if you just have a big hole in the window and the light coming in, the light comes and it hits that one spot on the floor directly under. What happens when you have like a little tunnel where there's sidewalls to the skylight, the light actually reflects off that wall and reflects back and really spreads it over a much broader area. So that's another kind of technique you can use to sort of spread your daylight around. Let me just kind of give you a notion of egress, just so you can start thinking about it relative to your building. Don't worry about exactly where you're going to incorporate it right now, but there is this notion of egress in the building, and something you have to consider in terms of how you're basically organizing the building and where the exits are going to be, how many exits, how many stairs are going to be in there, and it's really all dictated by code. And here's the basic principle. Let me just kind of plant it in your brain. We'll talk about it more next time. For any place in a building, there is a maximum allowable distance you can travel to the exit that you have to go ahead and provide to get people to safety. And it's determined by the occupancy of the building, it's determined by how many people are in the building, what the loading of the building is, how unsafe that is, but it's all about getting people to safety. And once we do get them to safety or towards exit, we often have to actually provide two different exits, because as much as we'd like to think that everyone's going to go running down the hall and go that way to get to the exit, if there's actually some sort of blockage, some sort of a hazard on that side, you have to give an alternate path. Okay, so egress actually turns out to be sort of a very big issue for buildings. We just have to sort of think about where your stairs are going to be, how many stairs you need, how many exits you need. It's all sort of based on some code requirements. So I'm just going to give you a sense of really what they are, just so you sort of start thinking about your building. Okay. It actually is all determined by code, and I just went looking down for the code section that was going to apply just online. So in the International Building Code, here's how it basically works. Now, you kind of need to be a lawyer or someone who has incredible patience to read through all this stuff, but every type of building has some sort of occupancy. And when you start thinking about an exhibition space, a museum space, it has its own kind of category. So assembly 1 is fixed seating, production, viewing, and performing arts like movie theaters, symphonies, theater. People they're in a really, really tight, and there's a lot of furniture to basically work around. Bad case. That's not our case. We don't have to worry about that one so much. That's a hard one. Banquet halls, nightclubs, restaurants, taverns, and bars. Some furniture, relatively dense packed, but not completely packed in there. Okay, they're A2. Assembly 3, art galleries, community halls, exhibition halls, museums. Okay, sounds like our building, something like that. Kind of not the densest, not the most dangerous, but yeah, kind of feels like we're sort of in here. A3 is probably what I would consider our building to be. Okay. So once you figure that part out, that's the first part you have to do. The second part is, okay, what does it actually mean? If it is an A3 building, how far can you go if there's a fire, if there's some sort of hazard? How far can we get out of there and still be considered safe? And for that, we're going to go to a different section of the code where it actually talks about the travel distance. So travel distance is really all based on the occupancy. We have hazardous occupancies where it's actually worse or has more stringent requirements. We're in A occupancy. So here's what we're basically have to watch out for. If we're in A occupancy, the distance we're going to need to be from any place in the building to an egress, if there's not a sprinkler system, is 200 feet. Okay. With a sprinkler system, we can actually get that up to 250 feet. 200 or 250 feet. So just relative to your building, you can almost think about, if you put a dot anywhere in the building, there has to be some exit somewhere within, we'll ultimately sprinkler your building, so within 250 feet. Yes?
Is that 250 feet, going through walls? Or...
It has to be a traversable path. Okay, so yeah, it's not as the crow flies. It's actually going to be, as we have halls, it includes all our winding around. So we'll talk about really how that plays out relative to your stairway and things like that. Yes?
Yeah, that's what does it include stairs?
No,
Like
actually,
going down a staircase.
no, it doesn't. Let's talk about that. It's actually a really good point because what ends up happening is this. Okay, if I move to the next one. What tends to happen is we design the stairs in such a way that they're fire insulated from the rest of the space. So the stairs are actually considered, if we can get you the stairs, that's like a safe route for heading out at that point. So there's some insulation that's kind of keeping the fire that's happening from here from spreading in. So they have self-closing doors, they have very thick walls, but it's really more just getting you to the stairway. And then from that, once you're in there, you're considered like somewhat safe. You ultimately have to be able to get out to the exit discharge, take it out, but it's really just to get you to wherever that is. So when you think about where stairs are located in the building and stuff like that, like even in this building, where are the stairs? The stairs are way down in the green atrium and they're over here in the blue atrium. So try it someday. March down and see how many feet it is from this one to that one, and then how many feet it is from the blue atrium to the red atrium. Because it is all very, very formulaic. And based on our application, really, affected with fire sprinkle and all that kind of stuff. So there really are rules to all this stuff that really determine the whole thing. And we'll go ahead and apply those and talk about how we build staircases and these kind of fire safe exits, and then really, as long as we've got this nice vertical shaft going up to the building, how that actually is a very cool place for us to think about putting our plumbing and our mechanical that has to go up and down to the building too. Because those shafts serve an awful lot of different purposes, and they all sort of work together to get the building surfaces up and down. It's a nice central spine where, no matter what happens in the building, that tends to be the one point that's very regular. It traverses all the levels. Okay, beautiful. Let us break for today. What's happening in terms of office hours? On Monday, you have some time set up for consulting hours, middle of the day. Is that what it is? Okay, very, very good. Okay, so 11 to 1, there'll be the guys will be in here kind of answering questions and stuff like that. If you have questions over the weekend, please drop them into Piazza so that we can go ahead and just start answering some of those. And again, between now and Tuesday, again, don't worry about getting the complete design of your building, but at least come in on Tuesday with some wall sections, trying some different things. Give me 1 or 2 or 3 different strategies for a clear scenario, some sort of shaded scenario, how it would work on the north versus the south. Just enough to get us going so we can start thinking about how creative you are. I'd love to see 4 or 5 different approaches as we start working in small groups so that we can compare and contrast and beg, borrow, and steal each other's ideas. Because it's all about kind of ultimately sharing different ways of approaching this. Okay, let us get out of here for tonight. We will adjourn.